She's led the creation of the United States Mortality Database, and more recently, the United States Fertility Database, which is coming together and has not been released yet, but is currently under project. She's has a joint researcher position here at Berkeley, the French Demographic Institute said, and she's published widely in mortality and other topics. Look forward to hearing from her today. So please join me in welcoming.
So thank you for the introduction, Dennis, and thanks for giving me the opportunity to present my work with you today. So I'm going to be talking about multi-morbidity at death and the US shortfall in life expectancy. And I'll start by acknowledging my co-contributors, Aline Desescales and France Mellet from INED, Francesco Grippo, Lisa Flora, Magdalena Papagallo, and Viviana Igili from Italy, and Sergi Trias from Spain. I also want to thank CIDA, which has provided some seed funding for this project. Okay, so what do we mean by multi-morbidity first? Multi-morbidity is the presence of two or more long-term health conditions, typically chronic conditions, in a single period. And why do we care about multi-morbidity? In contrast with simple disease processes, we care because multi-morbidity complicates the process of care in patients. For instance, typically patients require more coordination between specialists. They have longer hospitalization stays. There are issues of compatibilities in terms of drugs or procedures. And all of that makes caring for such patients much more expensive. In addition, multi-morbidity is increasing in the national population, especially in developing countries, both because of population aging. So as people get older, they have more opportunities to accumulate health problems. And paradoxically, also because of medical progress, because we're allowing now people to live longer with major chronic conditions, think about cancer or cardiovascular diseases or a disease of the nervous system like Parkinson, for instance. So there are more and more people in the populations of these countries living with multi-morbidity or multiple health conditions at the same time. Typically, multi-morbidity, so it's important to look at the prevalence and the distribution of multi-morbidity in the population for public health reasons. And typically, this is done using survey data. So there are big surveys in the US and other countries that try to measure multi-morbidity in the population. But there are a number of issues doing that when you're trying to make international comparisons, or even if you're trying to compare what's happening over time. And this is due to the fact that there is no really any standard methods to measure multi-morbidity. There are many different definitions. Each study has its own definitions, identifying different sets of disease and so on. The timing of the surveys when you do international comparisons is often varied. So it's hard, given change over time, it's hard to make a comparison when you have surveys for a different time period. The data sources, the way the data is collected or the sample is constructed might vary widely over time or across countries. And often in these nationally representative surveys, the institutionalized population is excluded. And these are typically people with more disabilities or older people than the general population. So you're seriously biased in your results when you want to have an estimate for the national population. And finally, surveys are very expensive, so they are not conducted systematically on very large samples. So the purpose of our project was to develop a new approach that will not be replacing what's been done before in the population, but that would come as a complement. And this approach is based on using information from death certificates to measure multi-morbidity, and more specifically, to use multiple cause of death data. And I'll explain in a minute what I mean by multiple cause of death data. This has the advantage to allow for very consistent measurements of multi-morbidity both over time and across populations. And then I'm going to illustrate this approach to look at how much of the gap in life expectancy between the US and a subset of other high-income population is explained by multi-morbidity. And the idea is that this analysis would help better understand the factors that are driving the US shortfall in life expectancy. So I'm sure you've seen this graph or a version of this graph before, but just as a reminder, this is life expectancy at birth for both sexes combined in 25 high-income populations, including the US and peer countries. So the US is in red here. You can see that up to the 1980s, the US was right in the middle of the trends for all these high-income countries. And then since then, it's progressively lagged more and more behind these other countries. And of course, COVID-19 did not help because the drop in life expectancy was much higher in the US and in other countries. And then in 2023, which is the last data point we have here, the US had not yet caught up to its level in 2019, while other countries, many of the other countries have. And so the gap continued to increase. Here, I'm representing the 3 countries that we've selected for our comparison. France in blue, Spain in purple, and Italy in green. We selected these countries. So we selected these countries because people in the project work from these countries and thus has access to the data, but also these are interesting to look at because they're very close to the US especially in the 1960s in terms of their level of life expectancy. And now they're among the leaders. So the top line here in the 2020s is Japan. This line, is there a pointer on this thing? Okay, the line at the bottom here, that's Portugal. But you can see that what there seem to have been conversions, basically, over these 60 years between all these high-income countries. The US is clearly an outlier.
This is both sexes together.
This is both sexes together, right? Oops. So these diagonal lines should not be here. I don't know what happens. It was not on my PowerPoint, so just ignore the gray diagonal lines. I hope it's not going to be the same for every graph. But anyway, what you see here is the values of life expectancy at birth for each sex in the 4 study countries. And the difference between the US and the other countries roughly stands at 3 to 4.5 years, depending on the sex and the country. And then the plot below just show you the death rates by age for each of those countries. And you can see, obviously, that not only is the US above the other countries in terms of mortality, but the gap is particularly significant for children and young working age adults. So this is easier to, again, forget the diagonal lines. So this is a better representation to look at the difference between the US and these other countries. These are the ratios of the age-specific death rates between the US and each of the represent countries. So France in blue, Italy in green, and Spain in red. I just realized I should have used the same color, but anyway. And again, you can see a big hump, especially compared to Italy and Spain for young working age adults. But you can also see that US has higher mortality at every age up to about 85 years, depending on the sex. And this was for year 2017, which is our study year. We picked the year before COVID, for which we had all the data we needed when we started the project. Okay, so let's move on to the method, the way we measured multi-morbidity in our study. So the idea was to use multiple cause of death data. So all of the causes that are reported on the death certificate, and actually I'll give you more information about that in a minute. And then we classify all of the deaths. So we have all of the deaths occurred in the country in the resident populations in the US, France, Spain, and Spain. And we classify each of these deaths into one of three categories, depending on the morbid process that led to death. So it could have been a simple morbid process, a multi-morbid process, or an undefined process. We'll get back to that in a minute. But once we did that, we computed age-specific death rates by sex and age for each type of process in the three countries, again for 2017. And then we used these rates to decompose the gap in life expectancy between the US and each of these countries by age, sex, and type of morbid process. Okay, so how many among you have ever seen a death certificate? Okay, well, less than half. So the death certificate includes a bunch of administrative information, which I'm not going to show here, and demographic information. You get the age and sex. And then the reporting physician is supposed to fill out a specific section that has to do with cause of death. So that's what you see here. There are two parts to the death certificate. So the first part here is for the reporting of the chain of events, the sequence of events that directly led to death. And this is organized in a way that the physician is supposed to start on line A, with the immediate, the last cause of death, what the person actually died from, and then go back in time to the initial cause of death, which is technically called the underlying cause of death. So again, part one is for reporting a chain of events leading directly to death, with the immediate cause of death, which is the final disease, injury, or complication that directly caused death on line A, and the underlying cause of death, the disease or injury that initiated, so the initial cause, the chain of more or morbid events that led directly to death on the lowest used line. So the physician is not forced to fill out all of these lines. If someone dies of a fall, it could just fall. And then on the second part of the death certificate, the physician is supposed to report all of the disease or the conditions that contributed to the death, but that are not part of the sequence reported in part one. So I'm going to give you an example in 1 minute. So here, for instance, on this death certificate, you have someone who ended up dying of a rupture of the myocardium. And this was due to some acute myocardial infraction that was due to coronary artery thrombosis, which itself was caused by atherosclerotic coronary artery disease. So this is the chain of events that led to death. But the physician also reported the diabetes, chronic obstructive pulmonary disease, and smoking in the second part, because these could have, for instance, accelerated the process or complicated care, or created complication for any of these conditions.
And this is the physician who fills this out?
Yes.
And is the physician looking at health records and stuff, or is it?
So for people who die in a hospital, yes, the physician would have access to all of the information to fill out the death certificates, or whoever is filling the death certificates. For someone who dies suddenly in the street, obviously they would not.
They don't go look it up. Okay.
No. There could be an autopsy. If someone, if there is foul play possible, then there's going to be an autopsy. So the first step in our method is, so all of these causes, so these, so there are like 1, 2, 3, 4, 5, 6, 7 causes of death reported. All of these are what we call multiple causes of death. multiple comorbidity. So it's a combination of all of the codes that show up on the death certificate, and they could be in the data file we use. There is space for up to 20 different codes of death, but none of the countries that we're using, the 20th column is always empty. I think for the US, the maximum was 16 or something like that. On average, for all of these countries, the average is between 2.5 and 3.5. So not that many. Okay, so what we do with this data is that, yeah, one thing I'm going to add is that the data file we get do not include all these text. All of these causes are converted into codes that are established by the World Health Organization into what's called a general scheme that's called the International Classification of Disease. So this ICD is revised every now and then. There's been like 10 revisions so far, starting from the end of the 19th century, to account for improvement in medical knowledge and changing diagnosis and things like that. So now, the one that's in use now in all of these countries, ICD-10, includes about 10,000 different codes. And so the codes start with a letter, A to, I think the maximum is U, and then after that you have 2 or 3 digits. And each of these codes is the same for all countries, representing the same codes of it. And it's typically done automatically, the coding is done automatically. And that's another reason why we selected these countries, because they all use basically the same software. So it's fairly standard that they use the same death certificate. They follow the guidelines of the World Health Organization to fill out the death certificate, and then they use the same coding software. Okay, so with the data file we get, we first label each cause of death, so the 7 codes that you saw on that example, as either originating, precipitating, associated, or ill-defined. So the originating cause is the condition that initiated the train of events that led to death directly. And often that's the initial cause that's corresponds to the underlying cause of death. So when you see cause of death statistics, for instance, in the US, in the newspaper, or even on the NCHS website, the deaths are classified according to the underlying cause, so the initial cause of death. Precipitating causes are the conditions that are caused by or directly resulting from an originating, so initial condition. Associated causes are the conditions that contributed or were associated with the morbid process, but were not part of the direct sequence of conditions leading to death. And often, most often, they show up on part 2 of the death certificate. And then finally, ill-defined causes are these unknown or not well-defined causes, symptoms, signs, or poorly informative of the death. So if we go back to the certificate I showed you earlier, the initial cause or originating cause, also designated as the underlying cause for this death certificate, is the atherosclerotic coronary artery disease. What I should mention too is that many physicians don't fill out the death certificate in the right order, and so you can't just rely on the position. You really have to look into each of the causes. So for this certificate, what's on line D here would be the originating cause. All of these on line A, B, and C would be precipitating cause. They are part of the sequence of events directly leading to death. And then what's on part 2 here would be associated causes or contributing causes. Okay, so what we do specifically is that we rely on something called the IRIS system. So the IRIS system is the system that's used by these countries to select it was developed based on the guidelines from the WHO. And its goal is to determine what are the relationships between all of the possible causes of death or all the possible ICD-10 codes. And so there are thousands and thousands of lines of code or of rules in the decision in the iris tables that will tell you which cause of death is likely the cause or the consequence of every other cause of death. And so that's what we use to determine the likely sequence of the morbid sequence, the chain of conditions that led to death.
So the input is just whatever's in those fields, and it figures out the order.
Right. So it looks at each pair of codes and determines, is this one a consequence of this one? And then that's how we label them. Okay. And then once we've classified all of the codes on the death certificate, we determine whether the death is to be classified as a simple morbid process, a multi-morbid process, or a defined process. So the simple morbid processes are the process with a single sequence of events leading to death. There could be many different codes involved, but they all the cause or the consequence of the other certificate. So there is a single originating cause and no contributing or nothing on part two. Multi-morbid processes are either death with two independent sequence of events, or one sequence of events on part one, and then at least one contributing cause or associated cause. And then undefined processes are death which have no specific cause on either part one or part two of the death certificate. Okay, so now some results. Do you have questions so far about the method? I know it's a lot of information, but basically what you have to absorb is that the goal is to classify death in three categories, depending on the sequence of events that have led to death. So if there is only one, it's a simple process. If there are multiple or one main one and then some associated cause, then we consider it a multi-morbid process, and then we have a defined process where we can identify and redefine cases first.
Yeah, just the ill-defined processes are just the form is not filled out. If the person died in the hospital, the physician didn't.
No.
Some period, no.
So it could be any. So it could be a note. Someone dies in the street, or it could be. I remember working in Nigeria once under cause of death data, and there were tons of certificates with cardiac arrest. So cause of death. Or the person was too old,
Yeah.
These are defined. Yeah. But even things like sudden death, unless it's an infant, which is like the sudden death syndrome, so there are all these things that are very vague and non-specific, or they're just a symptom that the person gets is dead. But so they're classified as.
That was my question.
Okay.
Just out of curiosity, if there's a multi-morbid death, but you're not doing an analysis of multi-morbid processes, how does that get reported? And you said like the NCHS website has deaths by cause and they use the underlying. Is it clear that even in a multi-morbid process, one of them is underlying? Or
yes, okay. Because the physician has to actually make a decision of what's indicated on the part one.
Okay.
Sometimes it's confusing, and there are some rules in the guidelines, so in the software, embedded in the software, that will make a decision. But the decision is not necessarily reflective of what will happen. Okay, so now some results. So here you see the ratios, same graph I showed you before with the ratio of the death rates in the US to the 3 comparison countries, here for men. But this time I separate out the rates by type of morbid process. So the blue line is for all morbid processes. So the blue line corresponds to what you've seen before. And then the orange line is for simple morbid processes. The purple line is for undefined processes, and the green line is for multi-morbid process. So the first thing it should not be distracted too much by is the purple line, especially for France. You can see it's below the 0 line because France has higher mortality from undefined processes than other countries. Yes, but what's most obvious here is that what really sticks out on the multi-morbid process, mortality from multi-morbid process, which is so much higher than for the other processes. Again, for children and young working age adults, but throughout the life cycle up to 85 approximately. And the pattern is very similar across countries, except for the fact that for Spain we have this spike, which could be due to some peculiarity in reporting a particular type of death. But anyway, even for the other two countries, France and Italy, you can see that the maximum for young age adults reaches 5 in terms of the ratio of the US to other countries. So the US has mortality rates, I'll get back to that. US has mortality rates from multi-morbid process that are 5 times higher than France and Italy and at least. So for women, we have very similar pattern, similar to men and across countries as well. So I'm gonna yes.
I'm just wondering, this is like surprising to me because typically when I'm thinking about mortality at younger ages, I'm not thinking about like chronic disease. So is this surprising to you that like multi-morbidity was higher? Like I think of like accidents and suicide and deaths with disparity.
So this doesn't show you whether multi-morbidity is higher or lower at younger versus older age. It gives you the ratio. So
relative to other countries.
So maybe it's very
higher. Okay, yeah, that makes sense.
Obviously it's much higher at older age, but it's more similar in the US to other countries at older age than in the younger age.
Okay, gotcha.
But you're right, that was one of the very striking findings, is that the fact that young adults in the US die at higher rates than in these other countries is in very large part due to multi-morbid processes. Yes.
I mean, are you going to talk about how many deaths are multi-morbid? Because it looks like, based on the fact that the all is not so far, like, is it not a huge share of deaths? Or
it is actually.
Oh, it is. Okay. Just because, like, there's a big difference in the multi-morbid deaths. Okay, you can do it later. I'm sorry.
Yeah. Okay, and so this is the same kind of information, but processed from a different angle. So here we are really answering directly the question we asked in the project, which is how much do multi-morbid process contribute to the US shortfall in life expectancy? So I'm going to explain these graphs. For this example, so this graph is the difference in terms of years of life expectancy, or let's say the mortality rates that contribute to the difference in life expectancy between the US and France for males. So overall, the difference is 3.25 years. So males in France have a life expectancy in the period life table of 2017 that's a little bit over 3 years longer than Americans. What you see here is everything that's above. So the sum of all of these segments is equal to minus 3.25 years. The way they're distributed is everything above the 0 line represents negative contribution, so lower mortality in the US. So as I mentioned before, France has higher rates of mortality from fibrosis than the US, and that's the pink segment that show up above the 0 line here. Below the 0 line, every segment reflects higher mortality in the US than its comparison country. And then the colors designate the type of morbid process that are contributing. So pink is ill-defined, blue is simple, and green is multi-morbid. So you can see, for instance, that of these 3.25 years of difference, nearly 0.2 years are due to infants, and most of it is due to simple morbid processes. So it's this first bar here. right? So in your head, you have to take this and remove that, and then you get the contribution of infant mortality to the gap in life expectancy between the US and other countries, right? Do you have a question about that? Because I'm going to show you a bunch of graphs. Okay, so now we're doing that for every country, for the 3 countries and both sexes or each sex. So France on the left, Italy in the middle, and Spain on the right, and then males on top, females in the bottom. You can see that this contribution of predefined processes, which is to the US advantage, only shows up for France, or pretty much. And that if we exclude these defined processes, the US is doing worse than all these other countries at every single age for both sexes, for any kind of, or for both simple and multi-morbid process, up to 80 to 85 years. The US has a slight advantage in older age mortality, though I can tell you that it's been eroding over time. But anyway, what you can also see is that the green segments are predominant here. So multi-morbid process contributes between 50 and 75% to the US shortfall in life expectancy. And the rest, for France, the rest is due to simple morbid processes. So to wrap up, so the main conclusions is that multi-morbid processes do contribute massively to the US shortfall in life expectancy, including for working age adults, which, as Paige remarked, is particularly striking. And since each cause has its own risk factors, that means that there is something general that the shortfall in life expectancy cannot be attributed to a single determinant of health, to a single factor. They're most likely to an accumulation of factors and possibly the role of structural or systemic issues in US society. And then the secondary conclusion is that I hope to have demonstrated the value of this multiple cause of death approach that can be generalized to many countries with multiple cause of death data, and which can provide a very useful approach to investigate, to make international comparisons of multi-morbidity. So the next step for this project will be to look at the specific cause of death that are involved. So in particular, what are the underlying causes that are associated with each type of process, simple and multi-morbid, and are they different? And then the second issue that we're trying to investigate is what are the most common combinations of cause of death in terms of when you have multiple originating causes? Is it pretty much always the same, and is it similar across countries, or are there differences when we concentrate on this multi-morbid process and we compare the US to other countries? So is it just the US has more of everything, or are there some specific combination of causes that show up in the US more frequently than in other countries? And again, this is to better understand what's happening in terms of the US disadvantage in mortality. Okay, and this is just the avoiding CDAS report. So that's it.